Welcome everybody to State of Data 2025. We had 2 days of State of Data. Yesterday we had the leadership track, right? Today it's all about technology. So I wanted to do a short recap of what we did yesterday. So yesterday our CEO Chris gave an introduction about how we look at things, and I think it was a very good summary also already of the first day. Unfortunately, he couldn't be here today. He woke up sick, so too bad. But so what did he talk about? He talked about like technology changing, right? About 10 years ago, we started Dataminded. Everything was Hadoop. And if you look at where we are now today, a lot has changed from technology point of view. Also algorithms, right? Linear regression all the way to large language models today. Really cool evolution to see. But like during all these things that have happened, some things have remained the same. And the things that have remained the same is some of those challenges, right? Some of those challenges are how to build solutions that stand the test of time. And these solutions, how do they actually bring value to end users? And so yesterday, we mainly talked about those last two topics. Today we'll be way more about technology and algorithms. So yesterday we had a panel discussion with different organizations. It was really interesting for me at least to see. Later on we'll share the videos of those sessions, so I can really recommend to look at the panel discussion. How do we as Dataminded actually look at these solutions, right? Dataminded is all about building data-centric organizations. And on one side, we really try to solve the technology bit, right? We really try to help organizations build modern data platforms, right? On the other side, we want to industrialize data products. And this is all about bringing value, right? Downstairs, if you go downstairs during one of the breaks, you should look at one of those panels. It says like, you know nothing until you deploy to production, right? Anything that's running on your local laptop doesn't bring value. But even if it's running in production, doesn't mean it brings value, right? There's a lot of steps that need to happen before you actually want to start working on something, before you actually want to start industrializing. And so that is all about like improving like this operating model. How do you work within an organization? And actually Johnny, who was standing in the back, gave an amazing talk about that yesterday. So if you have any questions about how we address this on an organizational level, definitely like during the break, talk to Johnny. The last word on this slide is skills, right? Skills, knowledge, right? And this is all why are we here today, right? We're here today to share some of our experiences, right? We're here today to meet interesting people, right? Or at least I hope you're here to meet interesting people. I'm at least looking forward to meeting some of you. And last but not least, to have some fun, right? We end this entire session with a game from Rashid, so I'm definitely also looking forward to that part. This is actually the full agenda. Like it's built up in blocks. We started 10 minutes late, so we'll have to make sure that either we catch up or we will be 10 minutes late. I think we'll be 10 minutes late. So given that, I'll actually do the first talk. I'll be talking about AI agents and data platforms. After me, it's Niels, who's going to talk about open source metadata catalogs. The last session of the first block will actually be Jelle, who I think was sitting all the way in the back, who's going to talk and share his experience of implementing data contracts at a customer. The second block is all about Jelena sharing her experience, like what's the difference between being a data engineer, what's the difference with software engineering, or what she learned along the way. Then it's Jos and Michiel, like DBT took the world by storm, everybody started adopting it. Will it remain here? Like, is it just like something that started and will evaporate, or is here to stay? What are the alternatives, right? So they're looking at that. We'll have another break, and then the last block is all about demystifying a little bit MLOps as a data engineer. Jesus and Mario will talk about this, and then, like I said, Rashid will be hosting an AI ML game, and we'll see if you can hack the vault. Right? This is the agenda for today. I hope you have a good time, and I think we can jump directly into the first talk. First talk I'll be doing myself, and I'll be talking about if AI agents will actually change how we work with data platforms. And before I start, I'll first introduce myself. Apparently I didn't do that, so I'm actually head of product here at Dataminded. I've had a lot of different hats over the years, mainly in technical roles, and this has been always my thing. I I like on a technical level, I like consistency. Consistency brings for me simplicity, simplicity brings for me velocity. So it's always something I strive for. But enough about me. Like, I want to know something about you. Who's using Gen AI today on a daily, on a weekly basis? Raise your hand. Kind of like I expect, like most people are using it today. And I think like, if you look at how we're using it, I think this one is the best example, right? Cursor. Anybody who has used it, most of the time loves it. It's also, I don't know how, if you know, but the fastest growing SaaS ever, right? It's reached 100 million ARR, like in no time, right? What else are we seeing? We're seeing a new sector, right? Generative business intelligence popping up. In Databricks, you have Genie Spaces. You have also, I think, AWS announced something about in their QuickSight solution actually having generative BI implemented in these products, right? And I think most of it, at least where I see it, at least in day-to-day work solutions, right? In Copilot for Microsoft or Gemini in the entire Google stack, where anywhere from in your agenda, in your calendar, everywhere you see generative AI actually pop up, right? And anybody has worked here with Gen AI, so probably I think all of you also had these situations where the model didn't exactly do what you wanted it to do, right? And here at Dataminded, we have a small intermezzo I do want to share with you, a very known one we have, and this was Jonathan. And Jonathan was working very late, a little before 12. He was trying, instead of finishing his presentation, he was playing actually with Midjourney, trying to generate a picture of two chickens running on a collision course on a horizontal line. And he couldn't get the line horizontally. And instead of finishing his presentation, he spent most of the night trying to do this. And like, what do we all do when you fail to get the model to do what you want, right? You call all caps and you say, what the fuck at the end. and that always solves it, right? No, of course, it doesn't solve it. Like, he just generated a whole bunch more pictures during the night, and he never succeeded. And actually, recently, we tested it again, and the line is already horizontal, but they're still not running on the line. So it's definitely like, I do think they accelerate this, but there's still clear limitations to these technologies, right? But if you think about this is where we are today, right? But where will we be tomorrow? And if we ask ourselves this question, like, who do we look to answer that question, is we look at the big players, right? We can ask like the CEO of Microsoft, and basically he's saying like SaaS is a thing of the past, right? AI agents are the future. And why is he saying this? Well, he's making an overgeneralization, and he's basically saying any SaaS product is basically just a fancy UI on top of a database. And that's an overgeneralization he's doing. But what he's saying is in the near future, we will not be interacting through UIs, we'll be interacting through agents, right? It's a bold claim. And you have this guy, right? The guy with the amazing jacket from NVIDIA. He's saying that IT departments will just be managing agents in the future, right? Another very, very bold claim. If we then look at Gartner, they're saying by 2028, it's not that far into the future, 15% of all day-to-day decisions will be made by AI agents. That's a lot of bold claims being made by very, very well-suited companies, right? So what are these AI agents, right? They're autonomous AI systems that, if you give it a goal, they will figure out what to do and actually execute it, right? That's the high-level thing. And every time a new buzzword, right? AI agent is the buzzword, I think, of the moment. Whenever it pops up, the first thing I do is like, do we at least all agree on what an AI agent is, right? And then you start looking, and you look at AWS, you look at all these different websites, and they're all saying the same, right? I think that's awesome, because most of the time, nobody agrees on what it is, and this time everybody agrees, like, this is what AI agents are, and what they do. And so we ask ourselves the question, what impact will they have on data platforms? Because at Dataminded, we build often data platforms for organizations. And how do you answer such a question is, you do an experiment, right? So we did an experiment, and it's just, I think 3 weeks ago now, we did an experiment with 2 teams, 2 days. Why 2 days? Why 2 teams? Well, I'm leading product, right? And I initiated this, and at Dataminded, we have 2 products, right? We have one product named Conveyor, which is all about building, deploying, and running containerized data pipelines. And so on the other side, we have another product, which is Data Product Portal, which is open source, and it's all about data product governance, right? And because we have full control over these systems, and they often play a role in data platforms, we wanted to kind of see like, hey, what can we do within our own products with these AI agents, right? It's an interesting thing to do. And so we had Niels, Robert, and Lieve in Team Conveyor, and we had Bruno and Stan in Team Portal trying to figure it out. So I'll walk you briefly to what they tried to build. And the first one is Team Conveyor. It's all about data pipelines, right? And any data engineer knows often a pipeline can break during the night. You get into the office, you look at okay, my pipeline broke, you look up which task has failed, you look at the log, you look at the root cause, you go back to the code, you fix the code, you build it, you deploy it, you rerun the task, and everything is fine. Why do I have to do this? Why not an AI agent, right? It can even fix it during the night and I don't need to worry. I just want something, perhaps a pop-up like, hey, I fixed your pipeline. That would be awesome, right? So what did they build, right? They used Crew.ai. It's an open source framework to actually try and build this in 2 days. They built one agent, which is basically a log inspector, and we gave it very crude tools, right? Because we want to know if these agents can be self-sufficient and reason for themselves what tools to use. So we gave it access to the Conveyor CLI, we gave it access to the full API of Conveyor, and we gave it access to specialized tools. I'll come back to the specialized tools later on. They also built a second agent, which is like a senior, like we say, it's a senior data engineer and is specialized in Apache Airflow and also in our abstraction Conveyor. So we gave it access to the code, which is actually running, and it gives us access to the actual documentation of Conveyor. And then we basically give it 2 tasks, right? We give it one task, it's like, hey, this failed, figure out what went wrong. And then we give it a second task to say like, hey, once you get from the first agent what's the root cause, figure it out in the code what's wrong, right? And that's what they tried to build in 2 days. What did Team Portal actually try to build? Well, they had something like, hey, we have this UI, why not just build a chat interface on top of it, right? It's the most common use case to do. But they also wanted to go a little bit further, right? They had something, okay, what if, right? For now, if you in Portal, it's all about requesting access to data product. If I request access to data, I'm usually waiting for the data owner, the architect, or multiple people to give me approval. Yes, for your use case, you can use this data. And that means waiting. Why do I need to wait? Why can't an agent decide for me if I can use this data, give it enough data? And that's exactly what they tried to build. They used another framework, they used Pydantic AI, and then they built first an agent that manages other agents. And then they had 2 agents. One is an expert data product portal user, and the other one is the gatekeeper that will decide if one data product gets access to the output of another data product. And then they gave it access to the full API of data product portal and to some number of specialized tools, right? Before I get to the conclusion how all this went, I do want to give some of the learnings we had along the way, right? How do all these frameworks work, right? All these libraries work more or less just based on LLMs, right? You give it a task, you give it a high-level goal, and the first thing an LLM will be asked to an LLM will say like, hey, what do you actually need to do? And it will actually, like, what tool should I use to answer this high-level question, right? Then it will, once it's decided which tools to do, it will execute that tool. Once it has done that, it will basically validate, hey, given the output of this tool, do I now have an answer that I can give back to the user? Am I done? If it is, it will just give the result. Otherwise, it will just go back into a planning mode. And that's basically behind the scenes. It's just an LLM reasoning with itself, building up more and more context until it actually reaches a result that matches the original input. That's how these things work behind the scenes. And so we had a lot of small learnings along the way, right? Models matter. Models matter a lot. Like O3 Mini, Gemini Flash 2 were by far, from all the ones we tested, by far the most performant. And prompts, we spent a lot, they spend a lot on prompt engineering because prompts matter. The more examples you give to a prompt and the more you formulate your prompt with more detail, the more accurate the results will actually be that it will be executing. And you can even use, right, your prompt to generate your prompts, right? Because that's how we do things nowadays. Very early already in the development process, we started implementing or integrating with tracing tools. Like very early on, we noticed the feedback cycle being very long. Like we had to wait a lot on responses. So I think even like after a couple of hours, Robert there integrated LangTrace to figure out like why is these feedback cycles taking so long. And there we learned already a lot of things like having multiple agents and passing context between agents, really not that performant, right? You lose a lot of time when you're passing these different contexts. So try to avoid that if you don't need it. And then another thing we learned is that output tokens are slow compared to input tokens. It's very easy to give a lot of information to an LLM, but really what the bottleneck is how many output tokens it needs to produce. So if you can reduce the amount of output tokens, you get better performance. Last but not least, I talked about these specialized tools, right? We give it all these agents very generic tools, right? We give it access to CLIs, to APIs. Even if these APIs are well documented, it's very, very wide tools that we actually give to these tools. So if sometimes you have two API calls that often have to use in succession, like get an idea of something and then use another API to basically fetch something using that ID, it's better to combine that into a single function and call that a specialized tool because you will get more reliable results. So the more specialized tools you give it, the better it actually works. So how does this entire experiment go, right? As with anything in technology goes, like day one was all smiley faces, everybody very, very excited, like, you know, you wire everything in, you get some good initial results, and like, you're looking forward to day two, right? And of course, like that I'm saying like this, you already know what happened at day two, right? They're not crying, right? Data engineers don't cry, right? With that being said, they were really skeptical at the end of day two about all this technology and where it was actually going. Now, remember, this is a conclusion of a two-day experiment, right? And what's the biggest problem they encountered? It's actually accuracy, right? And the number I'm showing you is not a statistical correct number, right? Because 50% would be really awkward to have as a correct number. But I asked the team, like, give me an indication, like, how many of the higher level goals you gave it, how many did actually succeed, right? And they shifted a little bit left and right, but in the end they said like, definitely below 50% actually failed. So if you give it a task, 50% failed, right? And they said there's plenty of room for improvement, but for production use cases, I will not get it into 90% or 100%. Like if you think about it, fixing your data pipeline in the middle of the night, like you don't want this to accidentally delete your entire environment or your entire project because it made the wrong reasoning, right? And then the second question is this result actually unexpected? And actually the answer is no. Like only after we did all these things, we started also looking at literature of like what the current accuracy is. And for example, OpenAI has this OpenAI operator where you can let OpenAI control a browser and try to execute tasks in a browser by talking to OpenAI. And for example, ordering something on Amazon through talking to it, and then you'll see it try to control a browser. And that level of proficiency on currently the best models is around 30%, right? If you look at the Claude, Claude machine user interface, like how well Claude can actually work at this moment with a general computer, it's only at 15%, right? You have here this test, the agent company, which basically has a bunch of agents trying to perform generic tasks within an IT company, and that sits around like 20% for like even the top models. So it's not completely unexpected that like, you know, we have a very specialized and scoped use case, so we get a little bit higher than this, but overall, if you look very wide, there's still a lot of steps to be made there. So what were then the key takeaways we drove from this, right? And that's like, one of the things is like, especially with the use case in Portal, chat interfaces, yes, it's nice, but it doesn't beat a good or well-designed UI. Right? It's kind of obvious, especially for simple tasks, which is a one-click in a well-designed UI. If you want to do in a chat box, you spend up typing, you spend time correcting what it's actually supposed to do, And so I think like a well-designed UI is not going to disappear anytime soon, right? I do think chat interfaces are useful because we could make it do things that were not supported yet in the UI, right? Things that it had to combine multiple API calls we didn't foresee in a UI, and this thing could, in some occasions, figure out what to do. Well, 50% of the time, right? So if you were lucky, you would get extra functionality without any effort. That being said, like I think there's plenty of places in products. And if you look at Copilot and if you look at what Gemini and Google are doing, they're just placing LLMs in very specific locations throughout their entire suites. And I think in a lot of our data platforms and other things, there are so many places where you can just add this little icon like, hey, summarize me my error log, because that's something that it overall did quite well. There's a lot of like these little places like, make me a recommendation for which data might be useful for this particular data product to have access to. There's so many little places where you can just don't need an agent, where you can just add LLMs, like generating descriptions, cleaning up things, keeping things up to date. I think there's so many places where you don't have to go to a very AI agent, but just add an LLM here and there in your user interfaces. Last but not least is, I do think these agents bring value, right? Even if it fails a lot, like I think there's definitely a future there, right? And the accuracy of these levels, actually, of these agents will actually go up, but I think for now you just need human oversight. So you want confirmation often either after the fact, before it actually does something in production, you want to confirm like, hey, yes, you're okay to do this. Or you want to know like, what are the steps you're gonna execute before it actually executes these things. So I just think you need to think about having some human oversight in there. And I think there's a lot of places, and that's for me the thing I'm looking forward to tomorrow, because I can see so many use cases where we're doing so many little redundant work and administration and things that could potentially be executed by these AI agents. So that's it for me. That's what I wanted to share. Any questions? Shoot.
So, yeah, okay, they're not accurate, we can't put them in production,
Yes.
but they can make us much more efficient.
Yes,
So,
yes, absolutely.
So, but I see it kind of different for the 2K work cases. For example, I see it more clearly for conveyor, where, you know, like, help me find go for the logs. That's super useful.
Yeah.
But for Portal, where you kind of need to approve assistance, like, also useful, or?
Yes, well, sorry. We talked about it, and for example, why it might be useful is it can do some reasoning, right? It can say like, hey, I think you should accept this because of these reasons. For example, hey, we had similar use cases, similar data products also having access to these data products, right? Or, you know, you should reject this because like this other data product clearly has PII information. You're trying to do marketing with PII information, you know, you should probably reject this. So you can give indications to the people who have to approve it to actually like give some incentive like, hey, this might be the reason why you want to accept it or you want to reject the actual data access.